So in this lesson, we're going to deal with outliers. So the first thing that you're going to do is calculate the mean of boys and girls shoe sizes. So one thing that I'm going to do real quick is show you how to download the data files. So you just click on this. So you could download this, or if it pops up as a Google file, you just click File, Download, and then download it as a Microsoft Excel. So the other thing that you're going to need to do is download the R code. So if I download this, and then the next thing I would do is open it. Now, that said, you're going to be needing to do a little bit of some debugging. So I'm going to show you what I'm talking about. So as I download this R code, I'm going to open it, and there's a little bit of some problems with it. So the first thing I'm going to need to do is import the data. So I go here to my environment panel, and I import the data set from Excel. It is in my, if I browse, that would be in my downloads. I'm going to just import the L3 data. It will get a little bit of a preview of this data. So if you look, I have the shoe size column, gender, height, and then runtime. So I'm just going to import that. And then if I go back to the code here, there's going to be some stuff that is missing. Oops. So I will go here to this. And I'm going to import my libraries. Now the data set is L3 data. I imported that. Now if you look for task one, I wanted to group the data, but if you notice here my group by like this is called a pipe here when you have that percent greater than less than, I'm missing the data. So I need to go L3 data, and then I create my pipe here where I go percent greater than sign percent, and then hit enter. And I hit run. And then this, on the first part, it actually, the gender column needed to be reassigned, and I fixed that earlier. So beforehand, when I imported the data, this was a character vector, and it needs to be a factor. So what you would do is go L3 data, and then put money sign, gender, and then put that assignment arrow, put as dot factor of, and then go L3 data, and then money sign, and then gender. So it just changes it. And then you can find the mean, and then you can also just find uh, the quartiles or the quantile of the shoe sizes, and it will list those. So it lists and if you go back to the output here, for the boys, it lists the minimum, Q1, the median, Q3, and then the maximum for both, and then I called the mean of both. So if you're looking here, that gave me this, the mean for boys and girls, and then also the 5-number summary, which is pretty cool. So what I would do then in looking at this is just say, all right, based on my output, I notice that girls have a larger mean shoe size than boys. Now, if I go back and actually look at the data, the first girl has a shoe size of 30, and that's probably an error. So I'm gonna probably need to fix that. So for some outliers, if you look at when I did a box plot, that 30 was in there. So that is clearly an outlier and probably needs to get fixed. So how you define an outlier though is a lower outlier would be we take the first quartile and we subtract 1.5 times the interquartile range, or Q3 minus Q1. So we do Q3 minus Q1 first, multiply that by 1.5 and subtract it from the first quartile. Any number below that would be outlier. So if you look here, we don't have any points flagged with outliers. For upper quartiles, you take Q3 and add 1.5 times the interquartile range, and you notice for girls we have 2 outliers. So here is how we can deal with outliers. That 1 of 30 was probably a mistake. So we can actually replace it as long as you know it's replaceable. So some data sets you would not want to replace the data. In this case, we can replace L3 data shoe size of the first one with 10. We know that that was supposed to be 10, we typed in 30. So now that we replace it, we can go back and find the data again. So if we did the quantile of the shoe size, we can now find the 5-number summary again. And if you notice, if I click down on the girls ones, the maximum is now 13. And then if I rerun the box plot for the girls, we notice that the only outlier here is 13. And then if you notice, say if I wanted a cool different color, I could go here on the box plot that I just ran. I can just press comma COL, the color equals, let's say I wanted them both in red, and I can just go red. That's a cool way to add color to them. So now you notice I have one outlier of 13, and that's probably supposed to be there. So we would leave that in there. You don't just remove outliers in the data if they're supposed to be there. So then you'd write down your minimum, first quartile, medium, third quartile, and maximum. Again, I would have students practice doing those by hand, have them have discussions. That's 30. Is that supposed to be in there? Is it not? Why is that so high? I mean, it's possible that someone has a shoe size of 30, but highly improbable. So now here in the practice problems, have them calculate the mean by hand, and then also with doing those outliers, have them group by gender, and then have them do the check for understanding as well.